Continuing our video series on APIs, we'll look at how to start a new API project by defining resources and reviewing possible data patterns. And we are doing a REST API first to get started. In future API videos, we will get into other API design patterns. Starting with REST, though, can help us determine the basics. Then if we want to compare it to another type of API like GraphQL or RPC, we'll have a starting point. This video is primarily targeted at developers and architects who are participating directly in the more granular API design elements. Partner, invest, or buy API.cc. Check out API.cc for more info. My name is Chris St. John. I'm a senior dev and architect with 20 plus years software development experience and with cloud and APIs. Recently at Nike and with startups. Message me to discuss your ideas and visit my site systemsarchitect.io for more info. This short video is for devs and architects. We'll be starting out with a REST API, defining resources and data modeling, then making a checklist of mistakes to avoid. By then, we should be getting liftoff by the end of this video. As I was almost finished making this video, a few questions came up. Should data modeling be done only with the database design and not the API? Yes and no. I'll explain. Some really good API training guides argue not to use a data model early on, as the database implementation and API interface are separate matters. I agree that they are separate tasks and issues. API paths should be planned separately from database implementation. However, the type of data model diagram we're doing here is called a conceptual data model, which is not intended as a final database implementation. This is a brainstorming tool for identifying resources, attributes, and potential future data patterns for planning. In the next video, we'll use a different consumer API approach for constructing API paths. We're using both methods. However, as a full-stack developer, I found that consumer API non-technical requirements can often miss items and could be improved if devs consider various other possible data resources in conceptual data models already. Just remember the data model we are doing in this video is not intended to be for a final API or database implementation, and that your API should be able to handle database implementation changes while remaining stable. A couple other questions. But isn't GraphQL, RPCs, or WebSockets better for my use case? Well, one of them may be better, but right now we're doing a basic API first for devs to compare and document those pros and cons. Another question I was asked is, I prefer to use GraphQL instead. Is this tutorial going to still be useful to me? And I would say yes, this is still going to be useful, even if later choosing a different solution. This way you get the basic resources, the attributes, and relationships, and you can start this as your API design sketch, but then switch to a different design type. Why are we starting with a REST API? REST APIs are good for initial assumptions in most cases. REST is the most commonly used API design choice. It's resource-centric, which means that it's a good place for us to start with data modeling units. Also, REST covers a wide variety of actions, but the main ones that we use all the time, such as create, read, update, and delete. So it's a good place to even start looking not only at the resources, but also access patterns. GraphQL, RPCs, WebSockets, and other API patterns may be preferable. After we've analyzed our resources and access patterns in more depth, we may realize we need a different API design choice. But we can use what we came up with our REST assumptions to compare. Before we start with data modeling, let's just keep in mind to avoid these mistakes. Not considering business requirements. Oversimplistic resource identification. Overcomplicating relationships between the resources. Overusing nested resources, ignoring performance implications, not clearly identifying read-only resources, not documenting or diagramming your API, ignoring pagination and filtering, In other videos, we talked about collaboration and gathering business requirements. So for now, as we do a conceptual resource diagram for brainstorming, I'm going to assume you have a list of business requirements already. Let's quickly look at a summary of a workflow for defining resources. Identify core objects. Begin by identifying the primary objects or entities that are part of your application domain. For example, in an e-commerce app, core objects might be users, products, orders, reviews, etc. Define relationships. Define how these resources relate to each other. Specify resource attributes. For each resource, identify the attributes that need to be included. Determine nested resources. Determine if there are any nested resources. Nested resources are resources that logically exist within another resource. For example, an order might contain multiple order items. Decide on read-only resources. Some resources or attributes of a resource might be read-only. For instance, in the case of an order, once it's placed, it might be that its status can only be updated internally and not via the API. Consider pagination and filtering. For resources that can return a large number of items, consider how you'll implement pagination and filtering. This can make it easier later for API consumers to work with your data. We are going to be diagramming these resources and relationships, and it's a very easy workflow to diagram these. One, we start with some resource boxes, just identifying at the highest level what are the resources. Next, we start making relations between them. Next, we look at primary keys and foreign keys, how they relate. Then we start filling in attributes and types of the attributes. First, let's identify core objects, and we're going to be using the diagram tool available at draw.io. It's more than capable of doing a good resource sketch of what we need, and it's free. Go to draw.io to download the free application or use the cloud version. And we're going to start with a template to speed things up. Go to New, and then the name of the template is called Entity Relationship Diagram. You may see that also abbreviated in some places as ERD, Entity Relationship Diagram. Click on that, and you should be getting started with that type of diagram. So now we need to identify and create primary data objects. And we begin by looking at objects in the domain of the app that you're developing. So for example, an e-commerce app, we have customers, orders, shipments, refunds, products. And remember, you're looking at high level here. We're going to go down deeper into the attributes of these later. You can certainly brainstorm with ChatGPT or Google to get additional objects. In this case, I typed in, I'm creating an online store payment system. What are some of the main objects and table names which may be required? And you see here that ChatGPT gave me a pretty good list right off the bat. Remember that we're just doing this to brainstorm API data patterns, and your API paths that we're going to work on later should not be dependent on this underlying schema. That will make it easier for you to just keep track of the highest level of resources that you're coming up with. So I took those down and put them into the boxes. I've collapsed the boxes. I believe in the template, they will be expanded with the attribute template aspect of it, but you can collapse it by clicking the plus or minus box inside the resource box. Now that we have high-level resources, think of them like database tables, though they may change. How are these resources related? There are a small number of relation types we can consider as part of this design sketch. The main relationships we look at are one-to-one, many-to-one, and many-to-many. One popular way of diagramming is called crow's feet style. And this helps us to quickly visualize the data relationships between different resources. In this slide, we see a number of different ways that you can symbolize a relationship, whether 0 to many and optional, or 1 to 1 mandatory, 1 to many, and so forth. Take a look at these. We're going to be looking at these in more depth in a few minutes. We're going to be looking at this type of visualization in future slides where we go more into depth on the diagrams, but you can either bookmark this slide or do a Google search on how you symbolize crow feet. This is one of the most common methods of doing it, but there are a couple other ones as well that you might run into. This is just what we're covering in this particular example. So here we are looking again at the relationships and how to diagram it. And right now we started with just customers, orders, and shipments as resources. And this is just an example of where, a customer could have many orders, but they don't necessarily have an order. So what the symbol is showing is one customer with an optionally many relationship there. And each order could have multiple shipments because perhaps one of the products ordered is not quite ready to be shipped, or maybe one is a bulky item and one is a very small item and they're actually done in separate shipments. So in this case, in one order could have multiple shipments as well. Or in the case where the order never shipped, we can still say that's optional. Perhaps the order was made, but then it was found out later that it was not in inventory, so it never shipped. If you have a collection of resources and you're not sure what the relationship should be, or if you just want to kind of unearth more ideas that you had not thought of, you can also query ChatGPT for this. Here I said, I'm creating a database in table schemas and need to create diagrams with the crow's feet method of showing relationships between them. My core objects include customers, orders, shipments, refunds. I'm a big believer that AI and ChatGPT can be used effectively to help you brainstorm, but just remember that you can sometimes get wrong answers from it. It's not definitive, so you should always validate these replies. We've created a collection of primary resources and we've defined relationships between those resources. Next, we'll start looking at the keys and the attributes of each resource. Next, what we need to do is specify resource attributes. And so when we expand the resources that we listed before in the draw.io entity relationship diagram tool, when we expand those boxes, we saw other rows and columns. And the left column is for noting whether it's a primary key or a foreign key, and the right column is for the field name and the type. For example, we have the customers table or resource, and we have a couple rows beneath that with the attributes for customers. And in the left column, if it is a key, if the attribute is a key, it will say either PK or FK, and some other data models that might have other things in there, but those are the main ones that we're going to talk about right now. And then we have the name of the field, which in this case is customer ID. We have the type, it's an integer, and it's not null. It's the primary key. And just a reminder, the primary key is just a unique identifier for each record in that particular table. We can also see, for example, orders in the rows down below. You'll see one that's PK, but you're also going to see FK. And FK stands for foreign key. And foreign key is essentially a field in the table that establishes a relationship with the primary key of another table. And so that basically creates a link between the two tables, indicating a relationship between them. There are a few general rules of thumb that you can use when you're doing this. We don't have to go into too much detail because we're not designing the entire database in this lesson. We're just looking at the basic data model so we can start doing the APIs. But usually the primary key will be, either an integer, it might be a UUID, which is a universally unique identifier. In some cases, it could be a string, but usually integer UUID would be the most common. And then another thing we can look at is it's usually in the format of, customer underscore ID or order underscore ID. Of course, if you already have a database with many tables, then follow the convention in that, but those would be typical. And then don't forget, for attributes, you would often have dates, date created, timestamps, date modified. Those are kind of gimme attributes that most tables are going to have. And primary keys are going to be most often not null. Once again, you can definitely use ChatGPT or other brainstorming methods to come up with some ideas. I also often look at other APIs and other database tables in the same application domain just to kind of see what they came up with, just to compare notes. So check other similar APIs, see any other previous developer ERDs or object mappings, use AI tools, or just check different SQL or SDK references for types. Here's an example of using ChatGPT to brainstorm for attributes and types. I just put in, I'm creating a schema for database tables for orders. What are some good attributes I should add to it and the types? And it gave me a pretty good list. Now keep in mind, your list is going to probably be different for, depending, it needs to be customized for what you're working on, your type of customers, and so forth. So at best, this is going to give you a ballpark just to get started. Don't look at this as 100% reliable, because we know that it does give wrong answers sometimes, it does leave things out, and it's not fully customized to your needs. But you can look at this just to get started, just to get your feet wet when you're designing a new schema. Of course, right now we're generating the schema, tables, and attributes as a brainstorming exercise only. Your API should be able to handle changes in the underlying schema for the database separately. So now we keep building the diagram out to look like this. We have the resource name. We have whether it's a primary key, a foreign key, or just an attribute. We have the types. We have the relationships between the resources. And we just expand on this. Years ago, when I had not very much experience doing this, I looked at these diagrams and I thought they were just crazy. They were just so big. But when you just get started with the individual small building blocks like this and slowly refine it, slowly increase the attributes you need, the types, do some editing, refinement, some iterations over it, then you're going to feel so much better. It's going to come out and you're going to look at what you have and it's going to help you map out the rest of your APIs. It's really not that complicated, and that's all there is to it. Things can get a little bit more complicated with nested resources. So spend some time looking at nested resources to find out what pattern you really need. For example, if there's a refund on an order, can there be a partial refund just on part of the order? Are there order items within the orders and the refund is for the order item and not the order? Some of these things are dependent on your particular use case of what you're working on. This can get a little bit tricky, and the way I usually handle it is just to come up with the options of doing it and then to think about it some more, weigh the pros and the cons of each approach, write that out, and if you have people you're collaborating with, other developers, or a lead in another group, if you are the lead, then go ahead and get some second opinions, and you'll feel a lot better putting these out, documenting them. It's a good idea next to start categorizing resources, whether they are read-only or whether they're going to be modifiable resources by anybody. start thinking about roles a little bit. If certain resources can only be modified by certain roles, and to brainstorm this a little bit and to document this. Some examples of read-only resources would be like, order status, payment status, order totals, inventory levels, timestamps. These shouldn't be able to be modified by the user. These should only be modified by the system in a certain process. Then you have modifiable resources, and these would be like shipping address. A user can change their shipping address, or a user using an API can change the address probably. Billing address, shopping cart contents, putting things in the cart, taking things out. Users should be able to do all that usually, or making comments on the order, changing the payment method. We've made considerable progress sketching out our entity relationship diagram and getting our API started. But next, we also have to look at a few other topics, such as pagination, filtering, and sorting. These are three basic pagination strategies that you will see out there quite a bit with APIs. First one, offset-based pagination, is where an offset and a limit parameter is used to get only a certain number of records. In this case, offset equals 20, limit equals 10, and that basically means skip the first 20 records and retrieve the next 10 records. Next, you have cursor-based pagination, and that's where there's an actual cursor parameter with an encoded position of the last retrieved record. And that can also be used to retrieve just a segment of the total data that you need. And then there's key set pagination, and that's usually used with, for example, timestamps, dates, where you can search or some kind of parameter, not always dates, but that's a common one, where there's a start date and an end date, and it just gets the records for that. There are a couple other pagination techniques as well, to mention default page size and maximum page size. And this is just basically the number of items returned in a single request. Smaller page size reduces the data transfer for each request and load on the server, but then it may require more requests to get a large amount of data. Larger page size is going to reduce the number of requests, but it can also increase the load on your server. Usually default page size is kept pretty small, in line with what most users would need. And maximum page size is more, but also not so much that it's going to create an extremely heavy burden on the server. You should also be thinking about filtering and sorting techniques that you're going to be using in your API. You have date filtering, status filtering, filtering by unique ID perhaps. And of course, there is a lot of different types of filtering syntaxes, but I've listed here in this slide several different ones that are commonly used. You can perhaps have a single field filter, a multiple field filter. You can use string matching, date range, and also you could have nested resources as well. Remember that we right now are just doing a sketch of the API so that we have a good idea of what we're trying to build, and also so that we can start with something and then more fully detail it as we go and document it so that we can build on it. Likewise, with these examples for sorting, you have a single field sort, a multiple field sort, descending sort, and multiple fields with different directions. We've come a long way in defining resources in this workflow. Let's just summarize this again, what we've done so far. 1, identify core objects. 2, define relationships. 3, specify resource attributes. 4, determine nested resources. 5, decide on read-only and role-based resources. And 6, consider pagination and filtering and sorting. Start making a rough sketch of the API routes. We're not getting into all the details on that in this video. We will be in the next video. But for now, just think about what are some of the common request patterns you're expecting. For example, /users is going to return a list of users. That's pretty simple. Or you want one particular user's details, it might just be /users/ID, and so forth. We've covered a lot, but there are many other points that we could also consider. For example, think about future needs. What is currently out of scope, but something that definitely could be potential future features? Imagine you've gotten your entity resource diagram all done, you're really happy, and then a stakeholder, product manager comes and says, oh, we forgot, we need to add this other feature. Think of some features they could come up with. Are you going to be able to fit those in? It's definitely important to get feedback from other users, staff, engineers for comment on your designs, even early in the process. Any feedback that they can give you that points out potential issues, potential problems, is just going to be something that you can fix quicker and easier earlier in the cycle of designing this API. And therefore, of course, it's very important to diagram and document this in the cloud so that you can share it with everybody. You don't want to have to explain it every single time. The better you have it documented, the better you can share it with many different people without having to take a lot of time explaining it yourself. If you've documented it well, if you've diagrammed it well, they should have a pretty good understanding of it. We're going to look a little bit more at best practices for API routes in the next video, but I just wanted to include this slide so you can start getting an idea of the types of routes that you could use. Some are straightforward, some are a little bit different maybe than you expect. Start looking at these, get ideas of how this relates to your API that you are developing. So we can just add one more point to our diagramming workflow. And again, let's look at the workflow. 1, make the resource boxes, the primary resources, the main tables of your database in your app. 2, draw the relationships between them. 3, get down the keys, the primary key, the foreign key attributes. 4, just the general attributes. 5, types for everything. And 6, those are the API routes, the endpoints. When you're done with that, you will have a very good idea of where you're going with this API. And before we conclude this video, let's just avoid these mistakes. Not considering business requirements, oversimplistic resource identification, overcomplicating relationships, overusing nested resources, ignoring performance implications, not clearly identifying read-only resources, ignoring pagination and filtering, and not documenting or diagramming your API.